how do you read a stem and leaf plot? A stem and leaf plot is just one way to organize data. What if a high school track coach asked his team members to record the number of miles that they ran each week? Well, the data might look something like this. Well, that probably doesn't tell the coach a whole lot. He could probably scan the list and find the lowest number of miles and the highest number of miles. But in this form, it's hard to tell much else. So what the coach needs to do is to organize the data. And let's see how that would be done using a stem and leaf plot. In this example, the data that we're looking at, the number of miles run by each student, are all two-digit numbers. So we have a tens place and a ones place. So for this set of data, the stem is going to refer to the tens digit. And the leaf is going to refer to the ones digit. Well, looking over the data, we see that the lowest number of miles is 15, and the highest number of miles is 44. So our tens digit, or our stem, is going to range from 1 to 4. So let's place those values in our stem column. 1, 2, 3, 4. In our leaf column, we're going to place our ones digits. So let's begin with all the numbers that are in the teens, or only have 110. That would be 15 and 18. So we have a 5 and an 8. And we'll add them to the leaf column. Next, we'll look at numbers that are in the 20s. Oh, we have 21, 26, 27, 25, another 26, and a 24. We'll add those ones next to the 2 in our stem and leaf plot. So we'll begin with 1, then the next highest number was 4, then we have a 5, and we had 2 6s, and a 7. Next, we'll look for the number of miles run in the 30s. So we have 35, 30, 38, 32, and 36. So we'll begin with the lowest digit, which is 0. Then we can go to the 2 in 32. Next we have a 5 in 35, a 6 in the number 36, and an 8 in the number 38. Now all we have left to do are the number of miles in the 40s, and we have a 41 and a 44. So we'll place a 1 followed by a 4. And that's our stem and leaf plot. So now let's take a look at the sort of information we can get from this plot. Well, right away we can see that the majority of team members ran miles in the 20s, and that ranged from 21 to 27. We can also see that in the stem of 2, we have 2 leaves that are exactly the same. So 2 members of the track team ran 26 miles. Because that's the only value that shows up more than once, we can call that the mode. So the mode of our data is 26, because that number shows up twice. We can also easily find the median. That's the middle point of our data. If you count up all the leaves, you would find that there are 15 leaves. The median would be the middle value, which would be the 8th number. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. 27 is the middle value. So that's our median. You can also find the mean or the average of all this data. The stem and leaf plot doesn't necessarily help you do that any better. I mean, you do have to add all of the values and then divide by the total number of values, which would be 15. But in order to find the mean, you really don't have to organize your data as we did in the stem and leaf plot. The other interesting thing to note is that the values that appear in the leaf column actually have the shape of a bar graph. So I'm going to highlight all the leaves. And you can see that we have a sideways bar graph. Now, what if your data consisted of 3-digit numbers rather than 2-digit numbers? For example, what if you were comparing batting averages? What would your stem and leaf plot look like then? Just as we did in the previous example, we would begin by locating the lowest number and the highest number. So the lowest number in this case is 285. And the highest number is 356. Our stem and leaf will still consist of tens and ones. The difference is that our batting averages are bigger numbers, so they have more tens. So let's begin with the smallest number, 285. We can think of this number as having 28 tens. So we're going to begin our stem with 28 tens. The largest number is 356. So we can think of this number as having 35 tens. So our largest stem will be 35. And then we can fill in the numbers between 28 and 35. Now we can fill in our leaves. We'll begin with numbers that have 28 tens. Well, we have 285, so we have a 5 in the ones place. And we have 288, and that has an 8 in the ones place. So we're going to put a 5 and an 8 next to 28 tens. Next, we'll find numbers that have 29 tens. We have 295 and another 295. So we'll write the number 5 twice in the leaf column. Next, we'll find numbers that have 30 tens. And we don't have any. In fact, the remaining numbers all have 33 tens. So we won't place any leaves next to 30, 31, or 32. But next to 33, we have a 0, a 1, and a 5. None of our numbers have 34 tens, and our biggest number has 35 tens, and it has a 6 in the ones place, so we'll put a 6 in our leaf column. And that is what the stem and leaf plot would look like for our batting averages.